Hey everybody, let's use Google Sheets in order to calculate the spread or the standard deviation of the data set. I am using the same document that we have been working with for a while here, the samples of human height, and I've gone to the tab that says standard deviation, and I'm working with this data set right here, heart rate, and I want to get kind of a sense of what the distribution looks like, so I'm going to click on chart. So it looks like it's kind of a bimodal heart rate, and that 75 is about the middle. When you're trying to think about what the standard deviation is going to be, it's if you go from like the middle to the maximum or the middle to the minimum, that is usually between 2 and 3 standard deviations. So like from 75 to 105 that's a distance of 30 beats per minute. So if that was 2 standard deviations, standard deviation would be about 15. If that was 3 standard deviations, it would be about 10. So we can say that our standard deviation is going to be somewhere between 10 and 15. And I like to do that just to make sure that when I'm done my work, just to check that the number that I get is reasonable. Right, Stella?
Yeah.
All right, so I'm going to add 3 spaces here, and then I'm going to scroll down the lock bar, just because that's the way I like to do it. Hang on, I didn't like that last thing it did. Let's try that again. Hold on. Here we go. All right. Well, we know that the process uses this formula, and this formula requires that we have n, the sample size, and the mean. So let's start by calculating those. The sample size we can get by saying the count of all of these measurements. So I just highlighted each one of the cells that we're going to be working with, and that tells us that we have 100 heart rate measurements. And then the mean, we'll use the same range of values, which I saw was from A5 to A104. So our mean is 74.5, pretty close to what we saw on the histogram. Now we know that we are going to need the deviation and the deviation squared. And I'm going to take those. Boom. You guys know how I roll. I like them to be bolded. I like them to be centered. And I like them to be centered in the other direction. For the deviation, this is going to be just a little tricky. You got to be careful. We know that a deviation means we are going to take the measurement of the heart rate, which is in A5, and we are going to subtract from it the mean, which is 74.5. Now, I like to, rather than typing 74.5 in here, actually click on that cell and just pull the value straight out of it. The reason I do that is that if the mean changes in our data, suppose we remove a measurement, it won't change this value right here, okay? But here's the catch. If you do that, you can't just copy and paste, because look, when we get to the next cell, it says that the deviation for a heart rate of 64 is 64, and that can't be true. Let's look at why. If I look at that formula, see what it did? It took the 64, and then it moved the cell being subtracted down by 1, so it subtracted 0 from it. We don't want that. We want to lock in the cell where the mean is housed, which is right here. It's in C2. So here's how you lock something in on Google Sheets. You want to come to the cell that you want to lock, and you do $C, $2. So $, column, $row, and you hit enter. Now if I take that and I copy and paste, you'll see how while the heart rate changes, the mean is locked in right here at C2. I'm going to take that, and I am going to, the next thing that we need to do is we need to square those deviations. So in this column, I am going to take the number that is right here in B5, and I am going to square it. Now I can copy those 2 cells, and I can paste their formulas all the way down the row. All right. So we have all of our deviations. We have our squared deviations. According to the formula, what we need to do with those squared deviations, recall, is take their sum. So I want the sum or the total, which would be equal to the sum of the cells in, let's see, this is C5, all the way down to C104. So there's our sum. Now finally, to get our standard deviation, which I'm going to abbreviate this way, what I need to do is take the square root, the formula for that is SQRT, of the sum divided by n minus 1. And n minus 1 is going to be the number that's right here, minus 1. You have to put that in parentheses, otherwise it will divide by this and then subtract 1. You'll get the wrong answer. So that gives us 12.9, which we should recall seems pretty reasonable since we knew it was going to be somewhere between 10 and 15. So now let's look at the effect that outliers have on the standard deviation. All right, so I've moved over into the next tab called standard deviation and outliers. Got a small data set here. I'm going to look at the mean. Oh. And then, all right, it's time for me to be honest with you. All these fancy formulas that we use to cook up the standard deviation right here, actually, we could have completely ignored all of that and just done this. Standard dev, STDEV, of give the range of data you're working with, boom, we're done. These two values, you'll notice that they should be familiar. That is because they are the same numbers from the last lesson. So mean of 72 beats per minute and a standard deviation of 5.7. I still want you to be able to work with Google Sheets in this interesting way like we did here, but you should know that you can just come up with standard deviation that way. Now, let's call this the regular data. And then I'm going to copy this data. And notice that if I wanted to, I could just copy these rows here. And it moved over so that here and here, these are using formulas for the second column. And now, let's suppose this value right here, I'm going to change it. You quit your job, you quit school, you move to the West Coast, you begin meditating in the forests daily, surrounded by the redwood trees. You grow a gorgeous beard, you start dressing only in linen. You become one with nature and the universe itself, and your heart rate lowers so low that none this low has ever been recorded before. We're going to turn it into a 26. Now, when I change this to a 26, watch what happens right here and right here. You got a prediction? Here it is. Whoa! All right, so this right here we know is a major league outlier. It made the mean smaller, and that makes sense because we took the smallest value and we made it even tinier, and so it dragged the mean with it. But look what happened to the standard deviation. The standard deviation got really big. And think about how that makes sense, because this value right here is very, very, very far away from the mean. It has a very large deviation. Therefore, we will get a larger standard deviation. The moral of the story, ladies and gentlemen, is that the standard deviation is not resistant to outliers. Please write this down in your book. Okay, here's what that means. You can only use standard deviation to describe spread if the data set is approximately symmetric. That means no skew or very little skew, and has no outliers. One more thing. Use standard deviation with the mean. So when you are using the mean to talk about center, you're going to use standard deviation to talk about spread.